Alright, hello again. This is sort of a part 2 video of the trig identities thing, but this time I'm going to do trig equations. So let's just get right into it. Let's start with this first one. This is the worksheet that we did for homework a few days ago, by the way. Alright, so let's start with number 1 right here. Okay, this is John from the future. So, well, the first time I solved this problem, I messed it up, so I have to film it again. Alright, so basically, for this problem number 1, we're going to subtract 2 from both sides, and we get 4 sine x equals negative 2. Now, we divide both sides by 4, and we get sine x equals negative 2 over 4, or simply negative 1/2. Alright, so sine x equals negative 1/2. If we take a look at the unit circle here, when we're trying to find when the sine is 1/2 in the 0, in this limited domain of 0 less than or equal to x less than pi over 2 pi. So we want to find the sine of negative 1/2 in one circle length. So negative 1/2, the sine is negative in the third and fourth quadrants. So negative 1/2, we have it at 7 pi over 6. So x equals 7 pi over 6. And negative 1/2 again at 11 pi over 6. These are the solutions for this problem. The next one is 4 secant x plus 8 equals 0. So first of all, let's subtract the 8. So we get 4 secant of x equals negative 8. All right, now we divide both sides by 4, and we get secant of x equals negative 8 over 4, or negative 2. Okay? Now we got to remember that secant is equal to 1 over cosine. So if we take the reciprocal of both sides, we get cosine of x equals negative 1/2. Okay, now let's go back to the unit circle. Where on this unit circle does cosine of x, or the x values, where are they equal to negative 1/2? Well, cosine is negative in the second and third quadrants. So we have negative 1/2 right here at 2 pi over 3 radians. So x equals 2 pi over 3. And we have another negative 1/2 right here at 7 pi over 6. So 7 pi over 6. These are the solutions to this problem. All right, let's do another problem. Let's do this number 5 right here. 2 sine squared x plus 5 sine x equals 3. So first, what we're going to do is we're going to subtract the 3 from both sides. We bring it to this side, so we get 2 sine squared x plus 5 sine x equals, minus 3 equals 0. All right, so now this resembles something that we've used quite a bit. Here, I'm going to write it right here. X squared plus, ax squared plus bx plus c. Or a parabola, quadratic equation. Except instead of x, we have sine x this time. So so some of you guys like to factor these, which is fine. That's a perfectly good way of doing this. But I kind of like doing the quadratic formula. So I'm going to use the quadratic formula on this. So basically, 2 is A, 5 is B, and negative 3 is C. So let's do the quadratic formula, which you guys should probably know now. So B is negative 5, so negative 5 plus or minus the square root of B squared, so 25 minus 4 times 2 times A, and then times C, which is negative 3, all over 2A, and A is 2, so all over 4. Now, simplifying this, we get negative 5 plus or minus the square root of 49 all over 4. Now, the square root of 49, if you don't know this, what are you doing in high school, is 7. So, negative 5 plus or minus 7 over 4. So, negative 5 plus 7 over 4. This is equal, negative 5 plus 7 is 2, so 2 over 4 equals 1/2. And then minus, so negative 5 minus 7 over 4. Negative 5 minus 7 is negative 12 divided by 4. Is equal to negative 3. So here, I'm just going to use the back of no, I'm just going to use this notebook here. So we solve for sine x. So that was sine x equals 1/2 and -3. Now, now the sign can only be in between 1 and -1. So this -3, it doesn't work out. We get no solution. So just ignore that. We're going to focus on sine x equals 1/2. Now, just like we did for the other problem, let's take a look at the unit circle. By the way, you guys are going to have to memorize this because she's not just going to just going to view a paper. So like we said before, so sine x equals 1/2. We got one at pi over 6. So x equals pi over 6. By the way, it's the same limited domain of between 0 and 2 pi. So we get x equals pi over 6 and x equals 5 pi over 6. X equals 5 pi over 6. So those are the two solutions for this one right here. We solved it using the quadratic formula and then use the unit circle from there. All right, let's do this next one here. We're going to solve it the same way. So 2 tangent squared of x minus tan x minus 6 is equal to 0. We're going to use the quadratic formula again, although if you prefer factoring, go ahead and do that. So let's do that. So b, so first of all, a is 2, b is -1, and c is -6. All right, so negative b, so 1 plus or minus the square root of b squared, which is 1, b squared minus 4, 2, a, and then c, -6, all over 2a. So 2 times 2 is 4. All right, now simplifying this radical, we get 25, so we get 1 plus or minus the square root of 25 over 4, so 1 plus or minus 5 over 4. So 1 plus 5 is 6 over 4, so we get tangent of x equals 3/2, and then 1 minus 5 is -4 over 4, so -1. All right, so tangent of x is equal to 3/2 and -1. Now tangent x, it goes from -infinity to +infinity, so it can equal just about anything. It can equal anything except for pi over 2, or yeah. So tangent x equals 3/2 and -1. All right. Well, tangent is defined as sine over cosine. All right, so let's figure out the tangent of -1, because tangent, this one's going to get you some weird numbers. So -1, so tangent, we go looking back on the unit circle, tangent is negative in the second and fourth quadrants. So in order for it to equal -1, like I said, it's sine over cosine. So the answer is going to be this. So 3 pi over 4, because you get a number divided by negative of itself. And same with down here, 7 pi over 4. So the answers are x equals 3 pi over 4, 7 pi over 4, and then inverse tangent, because in order to solve for x, like we said, we take the inverse tangent to both sides. I've kind of been skipping over that. But basically, the other two solutions, which are 3/2, are some long numbers that I'll display on the screen here. Those are the other solutions, which you can get using your calculator. All right, let's do one more problem. All right, so let's do this one right here, number 7. Secant x times sine x minus 3 sine x equals 0. All right, well, this isn't really a quadratic equation, so we're not going to solve it that way. What we're going to do is we're going to factor out sine x. So we get sine x, parentheses, secant x minus 3 equals 0. Okay, well, first of all, let's figure out when sine x equals 0. So I'm not even going to write it down. So sine x equals 0 in the between 0 and 2 pi domain at when y equals 0. So at this point here and this point here. So 0 and pi. So first two answers x equals 0 and pi. Now for the rest, for the other two, we have to figure out when secant x minus 3 equals 0. So what we're going to do is we're going to so we're going to write it like this: secant x minus 3 equals 0. We're going to add 3 to both sides and get secant x equals 3. And then on your calculators, you can't take the inverse secant. So what we're going to do is take the reciprocal of both sides. So we get, remember the secant is 1 over cosine, so we get cosine x equals 1/3. And now you can use your calculator and take the inverse cosine of 1/3. But that's only going to give you one solution. And so, because it's positive 1/3, cosine is positive in the first and second quadrants. So you're just going to add pi over 2 to whatever you get, and this will give you the second solutions. The two solutions for this I will put on the screen now. So the full solutions for this problem right here are 0, pi, and these two like that. Yeah, I mean, that's really all about it for solving the equations. I hope that this cleared up some confusion. I know it wasn't perfect, but hope it helped, and I hope you guys do good on the test. See ya.